Next unit for advanced math is graphing trig functions. And in this video, we are going to look at graphing sine. Okay, so the first thing we're going to do is just graph the parent function, y equals sine x. So no numbers involved there, just y equals sine x. And these are the values that we're going to use: 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to plug those in for x. So I'm just going to make a little table over here. Alright, here's my x values and my y values. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Alright, and all I'm going to do is just plug these values in. So I have the sine of 0, and you need to get these values from the unit circle. So you should have these memorized. Okay, and remember, sine is the y value from the unit circle. So the sine of 0 is 0. If I were to plug in pi over 2, the sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1, and the sine of 2 pi is 0. So I'm going to graph those points. So I have 0, 0. Let me make a point on my y-axis here. Alright, pi over 2, +1. Pi, 0. 3 pi over 2, -1. And 2 pi, 0. So when I connect these, it ends up making a sort of wave shape. Alright, and that pattern will continue in both directions. It would keep going back this way, and it would keep on in the to the right. Okay, so that is what the graph of sine looks like. Then we have some vocabulary words that we're going to talk about. Amplitude, maybe you remember from science, is the height of the wave. So if I go back and look at our graph, the amplitude of this graph is 1 because it goes up to 1. Okay, so that's amplitude. Then we have period. And the period is going to be the distance that it takes to complete one cycle. So here, what we graphed is one cycle. We start in the middle, it goes up to the maximum of the graph, down to the minimum, and back to the middle. That's one cycle. So the period of this graph is 2 pi because it took from 0 to 2 pi to complete one cycle. Alright, then we have a phase shift and a vertical shift. And a phase shift is just a horizontal shift. So if we just moved that parent graph to the left or the right, that would be called a phase shift. Vertical shift is exactly what you think it is, moving that graph up or down. So here's what some of these transformations look like. In blue is the parent function, y equals sine x. And then in green, we're going to graph a different function. So this time 2 sine x. So putting that 2 out in front changes the amplitude. It makes the max and min lower and higher. All right, so that's what it looks like when we change the amplitude. This is an example of a vertical shift. So this is sine of x plus 2, and it just shifts the entire graph up 2 places. Every point is up 2 from the parent function. Alright, then we have sine of x minus pi over 2, and the x minus pi over 2 part is in parentheses. Okay, so how I got these y values is if I plug 0 in, 0 minus pi over 2 would be negative pi over 2. And the sine of negative pi over 2 is -1. Alright, and then that continued from there. This is as an example of a phase shift. The green graph is just the parent function moved over 1 tick mark to the right. So if I were to take the blue graph, move everything over 1, it would line up exactly with the green. Alright, and then we have y equals sine of 1/2 x, and this is an example of changing the period. Alright, if you look at the parent function, from 0 to 2 pi is one cycle because it goes to the max, down to the min, and back to the middle. But the green function, sine 1/2 x, it goes up to the max and back to the middle, but to complete one cycle, it would still have to go back down and come back up. Alright, so this is an example of changing the period. We made the period longer by putting that 1/2 in there. Okay, so here's the standard form of the sine function, a sine of bx minus c, and then plus d. And if we put a number other than 1 in for A, it changes the amplitude. If we put a number in for B, it affects the period. If we put something where C is, it causes a phase shift. And if we put something where D is, it causes a vertical shift. Now, in all of those examples that we looked at, I gave you the 5 x values to use. I said use 0, pi over 2, pi, 3 pi over 2, and 2 pi. That is not going to be the case when you're graphing these things on your own. So here is how you're going to find those 5 key points. All right. The first thing you're going to do is find the period, and you'll see that T is the symbol used for period. I don't know why, but it just is. And so for the sine function, T is going to be equal to 2 pi over B. Okay, because the normal period is 2 pi. That's what we saw when we graphed the parent function. And then B would be the only number that could affect the period. So 2 pi over B gives you the period of whatever you're going to graph. So we're going to use as an example y equals sine of 2x. Alright, so if I were to graph this, the first thing I would do would be find the period. So y is going to, or t is going to be equal to 2 pi over b, and b in this case is 2. So the period of y equals sine 2x is pi. Alright, then I need 5 key points, and to find the first key point, this is what I'm going to do. Key point number 1 is always going to be, we're going to set bx minus c. Okay, remember from standard form, that's whatever's in the parentheses. So bx minus c, we're going to set that equal to 0, because if we look, when we looked at the parent function, it started at 0. I'm going to set that equal to 0 and solve for x. So in this graph, I just have the 2x equals 0, and so x would be equal to 0. So my first key point, if I'm going to make a table, my first x value would be 0. All right. To get the rest of them, I'm going to take the period and divide it by 4. All right, because I want 4 more key points, and I want them to be spaced out evenly over one cycle. So I'm going to take t, which we already found was equal to pi, and I'm going to put it over 4. So pi over 4, I'm going to add that every time to get my next key point. So the first one was 0, then I'm going to add pi over 4. So now my next key point is pi over 4. If I add pi over 4 again, I get pi over 2. If I add pi over 4 again, I get 3 pi over 4. And if I add pi over 4 again, I get pi. So now I have 1, 2, 3, 4, 5 key points. And then to graph this, all I would have to do is take these numbers and plug them in to whatever equation it is that I'm trying to graph. But I'm going to give you a shortcut. All right, we picked different x values for this graph than for the other ones that we use, because I picked x values that are equally spread out over one cycle. When you do that, you can use the same pattern of y values every time. So from the parent function, okay, remember it was 0, 1, 0, negative 1, 0, that pattern is going to hold true. The only time that those values would change is if you have something in the equation that is going to change the amplitude or cause a vertical shift. Alright, so if I look at this equation, there's nothing in front of the sign, so there's no change in amplitude. There's nothing added or subtracted outside of the parentheses, so there's no vertical shift. So that normal pattern of y values, 0, 1, 0, negative 1, 0, that's going to be what I'm going to use. Now, if you don't believe me, or if you're not confident in your ability to understand what I just said, you can always plug in these x values. So if I plug in 0, 2 times 0 is 0, sine of 0 is 0. If I plug in pi over 4, 2 times pi over 4 is pi over 2. The sine of pi over 2 is 1. Alright, so you can always double check yourself and make sure that your y values line up. Okay, I'm going to go through one more example, start to finish, just to make sure that we got this. So, y equals 3 times the sine of x minus pi over 2. That's what we're going to graph. Alright, first thing I'm going to do is find the period. So t is equal to 2 pi over b. B in this case is 1 because there's no number in front of the x, so 2 pi over 1 is just 2 pi. Okay, then I'm going to find my first key point. And to do that, remember, I'm going to take what's in parentheses, x minus pi over 2, and I'm going to set it equal to 0 and then solve for x. So I would add pi over 2 to both sides. So x is equal to pi over 2. So my first key point when I make my table, all right, is going to be pi over 2. That's my first key point. All right, then the only other thing I have to do is I have to take the period and divide it by 4. So 2 pi over 4 would simplify to pi over 2, and that's what I'm going to add every time to get my next 4 key points. So pi over 2 plus pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. And 2 pi plus pi over 2 would be 5 pi over 2. All right, those are my x values. Then for the y values, okay, remember we said that the normal pattern was 0, 1, 0, negative 1, 0. All right, but in this case, this 3 out in front changes the amplitude. So I'm multiplying 3 times whatever I get for the sign. So in this case, it would be these y values times 3. All right, so everything is going to be multiplied by 3. So 0 times 3 is still 0. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. And 0 times 3 is 0. So these are my actual y values that I'm going to use. 0, 3, 0, negative 3, 0. So when I go to graph this, I have pi over 2, pi, 3 pi over 2, 2 pi, and then I need another mark so that I can have 5 pi over 2. And then I would have to go on my y-axis up 3, down 3, so I have pi over 2, 0, pi 3, 3 pi over 2, 0, 2 pi, negative 3, and 5 pi over 2, 0, and draw my wave. Alright, that's it for graphing sine. If you guys were absent and working on homework, there is a template so that you don't have to draw your own axis every time. It's already drawn out for you. And then the problems are a separate file, and everything's posted on Fusion.